coming tonight, and thank you to Lerro for hosting the SMPTE meeting tonight. We have a multifaceted presentation this evening. The first to be going will be LiveU, and then we will have NewTek doing a presentation, and followed up by Panasonic. Tom knows all of our presenters and will give us a quick little description of who they are. So thanks, guys.
Let me have this. Yes. Hopefully I won't rumble with the microphone too much. But yeah, welcome. I am authorized to speak for my boss, Matt Murphy. He's glad you're here. He couldn't be here himself, but really appreciate you coming. We had a number of folks show up earlier today and see similar presentations. So tonight, we'll end up with Panasonic, both Rick Lamb and Stuart Lamb, no relation, will be talking to us about the Panasonic products. The second talk tonight will be Chris Burgos, who will talk to us about NewTek and NDI. And then our first speaker tonight, who I'll leave you with, is George Klippel. He's the director of channel for LiveU. And I know you guys were all in the showcase area looking at the equipment and stuff like that. So I got a good eye full of stuff. I hope you enjoyed that too. And that area will be open at the end of this, the three talks we have briefly, so that you can get any questions answered and so on. So we're glad you're here. With that, I'd like to introduce George Klippel. George. I'll switch this over.
Thank you very much. And thank you for that wonderful round of applause. As Tom mentioned, as you switch around to my slide deck, my name is George Klippel, Director of Channel Sales with LiveU. And I'm going to be talking about our product portfolio in just a second. But before I start, just by a show of hands, how many people in the room either use our equipment or have heard of LiveU? Oh, that's great. Great. Good majority. So tonight, what I plan to do to augment what we're showing out in the demo area with my technical engineer Sebastian at our table. So please feel free, once I'm done, or once we're done with all the sections, to go back out there and check out our gear. I wanted to just give you an overview of who we are, what we're doing, and some of the products that we have out there and what's coming down the pipe for us. So LiveU, who we are, we're reinventing live video solutions. We're the experts in this space. We have over 20 patents for the creation and development of live video over bonded cellular network. We have a very unique technology called LiveU Reliable Transport. That's our secret sauce that makes sure that our customers can deliver the highest quality content to our online audiences. And I'll explain more about that in a few minutes. We offer end-to-end workflows for both broadcast and online. And when I say broadcast, this group for sure knows what broadcast means. But when I refer to online, it's kind of an umbrella term for us. That means not only online markets, but that also kind of encompasses verticals like education, verticals like house of worship, etc. Anyone essentially who wants to deliver compelling video to an online CDN like Facebook or YouTube or what we're doing like streaming tonight. Our centralized management system is all cloud-based and manages our entire product portfolio. So anything you could do with our units, our LiveU units, can be done anywhere from a tablet, Mac, or PC. So from anywhere in the world, you can manage our entire ecosystem. And then lastly, we have an advanced physical and cloud-based video distribution solution. So not only can you go to a single distribution point like we are this evening to YouTube, you can go to multi-point distribution and do things of that nature. So we were founded in 2006, so just over 10 years, shipped our first product in 2008. We have over 6,500 field units in over 80 countries, 3,000 plus end users, producing tons of content on a daily basis. Over 195 terabytes, almost 200 terabytes of monthly live transmissions. We are headquartered in Hackensack, New Jersey, right up the road. We have offices around the world with 24/7, 365 worldwide support. Our support in North America is done right outside of Hackensack, plus one guy in Hawaii. I tried for the Hawaii job, didn't get it, but he's there on the overnight shifts. So if he ever answers the phone, expect a mahalo or whatever they say over there. We are the industry in live video over IP and cellular bonding with over 65%. Oh, this does work. Look at that. 65% of the live shots that you see on broadcast TV today are all done using our gear. So whether it's breaking news, the hurricane coverage, or what you see out of Capitol Hill on any network, they're going to be most likely using a LiveU backpack unit. So when we talk about, and that's the backpack right there on this guy's back. When we talk about our product portfolio, it's an award-winning portfolio. There's 4 segments to it. A portable section, which we call are the field units. And these are the units that you connect to the camera, HDMI or SDI. And that's basically what does the encoding of the video signal. We also have software for your smartphones, your iPhone or Android, and even software for your Mac that runs software essentially to do the encoding. We have vehicle and fixed solutions like an extender or other mounted solutions that you can put into a vehicle, if you will, like a SAT truck or a TV truck if you want. And even decoders like the LU2000, a cloud server, and our new LU4000 for 4K streaming. And as I mentioned before, everything's managed by our central IP-based cloud management platform. We call that LiveU Central. So if you look at our portfolio, and these, all of these except for the extender on display out there tonight, at the entry-level side, we have what's called the LiveU Solo, the first bonded cellular solution for under $1,000, $995. And that device is designed just to do one thing and one thing extremely well. Get your content to the online market space, only online. So to Facebook or Twitch or Wowza or YouTube or any of the places, but that's all it does. It's just made for the online market, simple to use, easy to use, and very affordable. The other systems that you see at the top, the 200, the 500, the 600, those are our broadcast type of units that have multiple modems. The 200, for example, has 2 internal modems plus 2 external modems. The 500, the 600 have 8 modems. Plus, you can add an extender that will give you 6 additional modems for capacity and redundancy. And plus, these modems here in the extender are ultra-high frequency modems, so you can connect those to any of our professional models here, the higher-end models, if you will. And it not only gives you additional capacity, but it allows you to go to the next available cell tower. So when you use your cell phone in a crowded environment or in any environment, cell phone goes to the very nearest tower that you connect to. So if you're using Verizon, it goes to the closest Verizon tower. Sprint, same thing. If you're at a shoot, like for the Super Bowl, and everybody, 100,000 people that are using their phones and streaming and Snapchatting and Facebooking, right? It's sucking all your available bandwidth for using cellular bonding. Well, with our extender, you're able to go to the next tower out and get your shot out and get it out safely and securely. Bond flow is pretty straightforward, and just you may already understand that, but I just wanted to make sure you got it. Field unit, connect to the camera, HDMI or SDI. Then you take your multiple cellular modems, AT&T, Sprint, Verizon, T-Mobile. Plus we can take Wi-Fi or Ethernet connected. We bond those together for a reliable connection, encode your video into IP packets, send it across the internet, and then it comes out either to a physical server or a cloud-based server where you could send it out NDI, SDI, H.264, or H.265 even. And you could do any of those simultaneously. So you could send an SDI signal or an NDI signal the same time you're sending something to Facebook or YouTube. So H.265 has gotten a lot of press lately, and rightfully so. If you look at H.265, which will be on the left here, and H.264 is on the right, if anybody has been around for a few years like I have, back in the day I used to work for Avid Technology, and in the old days Avid used to do split screens with beta SP footage. And they would say, this is AVR 27, our first 2-field resolution. Look at how cool it looks against beta SP. And the engineers would all look at it and try and decipher, is it good enough to go to air? And now what you see with HEVC, H.265 if you will, versus H.264, this is at 1 meg. And by the way, this was acquired footage at 4K, down converted to 1080, and it's been put onto my computer, right? So it's off a computer screen, so take it for what it's worth. This is 1 megabit per second. It's kind of similar, right? It's not that noticeably different. But when you start getting up into a higher bit rate, so let me just move down to save time here. This is an example of H.265 at 4 megs versus H.264 at 6.5. So this is, again, a little, 2.5 megabits more at H.264 versus 4 megs on the left. Look at the difference, almost negligible. You can't really tell a difference. But with the H.265 signal, you're saving over 2.5 megabits of data, right? So it's saving on your data plan, it's saving you money, and that's a huge reason why H.265 is being talked about and why it's so important in this industry today. And the nice thing about the LiveU units and the implementation of our H.265 is that we allow you to stream in H.265, but we record at H.264. And the reason for that is no nonlinear editing system can edit H.265. So you got to cut on Adobe or Avid or Final Cut in H.264. Okay, sorry. All right, moving on. LRT, this is our secret sauce. I mentioned I'd get to this. It does 4 things: packet ordering, dynamic forward error correction, acknowledge and resend, and adaptive bitrate encoding. We have this patented. This is, again, as I mentioned, our secret sauce. Others can do a couple of these things like packet ordering or acknowledge and resend, but we're the only one that does all 4. It's a little bit easier to explain on this next slide. The top line that you look at here is the aggregated available network bandwidth. The line right next to it is the actual video bitrate, what we're streaming. And then the bottom line is the actual audio bitrate. The audio bitrate in a LiveU environment is always in sync and always consistent. So if you look at this slide here, you'll notice there's a network fluctuation right here. So the bandwidth drops a little bit. It's kind of the equivalent of going, bless you, from 4 bars on your cell phone down to, let's say, 2. That's what this is right here. And right below it, you'll see that the video bit rate drops down. You notice that right there? Okay? That's because of LRT. And you see in the next circle, the encoder, the bit rate goes back up. Notice that? That's because the network bandwidth came back up. So just like a wave, LRT automatically is able to compensate and adjust the video bit rate on the fly as the network bandwidth adjusts. So when you have a catastrophic failure, like here, the network bandwidth drops out almost down to nothing. We drop the video bit rate. We're still streaming, still delivering you a quality signal, getting your stream out to the web, all done because of LRT. Now, the reason this is important to explain and why it's our secret sauce is because other units on the market require you to set a consistent bit rate. If they do, what happens in this zone right here? Come on, you're a bunch of engineers. Somebody. Anybody say, did somebody say drop out? All right, thank you. That's right. It's going to fall off a cliff. It's going to freeze. Your video is going to freeze. It's going to go to black. It's going to drop out. And that's what happens with a device that requires a set bit rate, right? So that's the advantage of LRT. And that, my friends, is as technical as I'm going to get with this group. Okay, so on the high end for us, LiveU's highest end product is the LU600. Has an MSRP price point of around $25,000. Includes HEVC. Oh, yes?
Just an FYI, it's simply we don't talk prices.
Oh, okay, very good. I didn't know that. Hang on, I got a call here. Oh, yes. SMPTE Director? Oh, I'm sorry, I talked prices. I will not do that again. Thank you very much, sir. It is my first SMPTE meeting in a long time. So I will not be talking prices, but this is our top end unit, the LU600. It has a 50% bitrate reduction to broadcast more hours on the same data plan with our HEVC card. It has 6 to 8 built-in cellular modems. It can stream up to 20 megabits per second on an Ethernet card. Has a high-quality built-in 5-inch display with capacitive touchscreen. The backpack has remote control on it, 30-second or less boot up time. The battery internally is a 4-hour internal battery. Plus we have V-mount and Anton Bauer mounts if you use those. And then we can do 4K streaming with our 4K server. On the other end of the spectrum is our Solo HDMI. It's the first bonded solution that has a 3-hour battery life that also has LRT and is managed by the Solo portal. Now you can stream to multiple destinations, single destinations with this unit, and that's what you guys are using tonight actually to stream to the YouTube channel. At the end of the month, we'll be offering for the very first time on any system real-time cloud graphics So you'll be able to do like lower thirds and bumpers and banners and logo bugs, real time in the cloud, on the fly as you're streaming. So that's going to be a really huge thing. I'll take questions at the end here because I'm getting close I don't want to run out of time. We do have a partnership with Panasonic as well as some others which we'll cover. But Panasonic's here today participating with us. We actually have full integration with our API to their streaming cameras, these ones right here that you see. And what we can do is actually within our platform management tool called LiveU Central, we're able to control things like focus and iris and zoom, white balance, and even gain. So while your camera person, maybe a freelancer, is out in the field, within the environment, the LiveU environment, through our management portal, you're able to take control of the camera and not only adjust and start and stop the streaming, but you could control all these other features if you're using these Panasonic cameras. So the camera person can really just focus on the shot, not worry about camera setup and all those other things if you want them to. So it's a really nice feature. We've been integrated for over, I think it's been over 2 years now with Panasonic Integration. It's really tightly integrated into the LiveU Central application. Now talking a little bit about NDI integration, NewTek is up next. NDI is their application that they support. We also support it as well with our server. We have the LU2000, which is the unit that receives the feed from the field unit. So you have a field unit that attaches to the camera, and it sends the signal back to a unit like this one here, the LU2000. You can receive up to 14 streams simultaneously, so up to 14 different units can be sending a feed back to this box here. It has a single output, dual output, or a quad output. It supports not only NDI, but it supports RTMP or SDI. It's got the LRT, as I mentioned, as well. Full support for IFB. So if you need to do talkback or talk to your camera folks or talent in the field, it supports IFB as well. We just released last month the LU4000, which supports 4K bonded cellular streaming. It's SD to a 4K P60 resolution on a single 12G SDI output. So this only has a single output where the other option, the LU2000, has 1, 2, or 4. And again, everything else is the same. LRT, IFB, support, full management and control over LiveU Central. So NewTek, NDI, and LiveU, from our perspective and working with folks like Lerro, and that it's like the glove and hand type of thing. LiveU goes perfectly with a NewTek environment if you're using NewTek at all. And it works well with many, many other products, but NewTek in particular, because it allows you to add the graphics lower thirds, but it also has really tight integration with the NDI platform. And let me show you how it's typically deployed. This is the normal or standard NDI typical workflow on the acquisition side. You have the field unit over here doing the bonding, like I mentioned before, and then it outputs straight to a LU2000, as I mentioned, and then you go NDI into your TriCaster. That's the typical workflow, very straightforward. And that's people how they use it probably 90% of the time. The other type of workflow, and one of the key things that LiveU makes so well with NewTek is we're used on both sides of the equation with them. This is the distribution workflow. So let's say you're doing a multi-cam shoot somewhere, or you're covering a convention or a conference like this, and you don't want to pay for an internet drop, right? And you want to use us as transport. So you connect the TriCaster via SDI to our unit, and we bond that connection and send it out to any one of these destinations, right? Or multiple destinations simultaneously. So you're using us as transport. So we can be ingest into a TriCaster environment or production environment, or output as distribution. Everybody with me? Yep. All right, good. The other and final application that we see a lot of use in is what we call the multicam environment, or also referred to now as an at-home production environment. Some of you may be familiar with it as like a REMI type of application, where you're taking multiple cameras, bonding them together, sending it through to a output server like a quad or something, and then output to a TriCaster. For us, this is over the last 8 months or so, the at-home production model has really taken off in the industry. It started more in sports and athletics, and now it's moved and crossed over into production, into many other facets of of life, if you will. And for us, at-home production is nothing more than essentially leaving your production environment at home or here at Lerro and sending all your camera operators out on site with the backpacks and transmitting everything bonded cellular back to your head end and doing the production, instead of taking an entire SAT truck or production truck out to the site or a fly pack out to the site to do the production. So it really does, you don't need miles of cables and stuff like that anymore, right? And now the case study that we started this with was NESN, New England Sports Network, home of the Boston Red Sox, right? So what we did is about 3 years ago, NESN wanted to use our technology, and they'd been using it, but what they've been doing was covering the spring training by sending a SAT truck, doing the normal satellite truck down to spring training with the full crew and everything else that you need to make a SAT truck work. And at a spring training event, they had 6 cameras covering this event. So it was a big expense for them. And their production facility in NESN headquarters in Boston is amazing, right? So what they did was they went down and instead of sending a SAT truck, they sent 6 cameras and 6 backpacks and installed a server back in their headquarters in Boston, where they play there. And they just sent a producer down and their camera people and did the whole production with no satellite truck, no need to pay for airfare, no need to pay for lodging and meals and everything else. So they did at-home production. So basically did the whole game. Everything was in sync. Everything, all the cameras sync up, send it back to the head end. The head end does all the production, inserts all the Chiron, inserts all the score, and streams it out live. So that's what at-home production is. And for them, they didn't give us the actual cost, but it saved up to 75% savings for them. So they saved on travel, satellite time, and on-site truck rentals and use. So it's huge for our industry, and is really changing the dynamic on how people think and what they use. So my last slide, and I'll take questions after, is our strategic partnerships. We have partnerships with all these folks up here, social networks, one-touch integration with Facebook, YouTube, Twitch, Twitter, Switchboard. Sebastian can show you all of that once we go into the demo sessions later. AP, we've established AP Community, which used to be called LiveU Community, a community of freelancers throughout North America that have LiveU gear and will work with any of our partners. Camera vendors like Panasonic, NewTek, platform providers, also working with Avid to, in the future, introduce integration with iNews and Media Central UX, and then Hughes Satellite for hybrid cellular and satellite solutions as well. So we have deep integrations with partners, and there's more and more development being done on that front from LiveU's perspective, and you'll be hearing more about that as we approach and get closer to NAB. So that was my last slide. This is my thank you slide. Now I'll open it up real quickly for some questions, since I think I have 2 minutes, 3 minutes.
George, make sure you repeat the questions.
Yes, I will. I'll repeat the questions. Yes, go ahead.
That intercom is over that LU600 as well?
Yes, the question is does intercom come over the LU600? So our LU600, the 500, and the 200 all have IFB capabilities, and that's through our server that comes out of the server. And so yes, it's just like the earpiece they wear, but yes, it does come out to the system.
Camera operator. Am I able to talk to my camera operator in addition to my camera?
No, it's, well, unless you split it, but it's only one output. Yeah, so the question was if you could talk to both talent and camera operator, and it is only one output, so you'd have to split that. Yes, sir.
You mentioned live events and using the NewTek to feed the transmitter.
Yeah.
What's the cost usually if you're not doing that the old-fashioned way?
Yep.
What's the cost for bandwidth on site?
Yeah, so the question is about using NewTek for live events and feeding output to live transmitters, right? And what that cost is. That's a tough question to answer because, well, I would say it ranges from a few $100s to thousands of dollars, depending on where you're at. If you go to the Philadelphia Convention Center, that's a union shop. Asking for an internet drop is going to be thousands of dollars, right? And if you go to a local hotel here, you might get it for $500 or $1,000, right?
So I'm thinking if you're broadcasting a concert, what's the cost of that actual bandwidth? like at a major venue?
Yeah, so you're asking about the cost of the bandwidth at a major venue. Again, it's going to be the drop typically, or the satellite feed. So that's a very tough one to answer because it can depend. It's going to be a lot. It's going to be a lot of money, and it's going to be dependent on the venue. It's really hard to quantify, but it's a lot more than what it's going to cost to broadcast with a LiveU unit.
No, I understand.
Yep. Yes, sir.
What's typical latency?
What is a typical latency? On all of our units, except for the Solo, all of the latency can be set between 1 second up to 20 seconds. And by NAB time, we'll have it ability to set to sub-second delay at 0.5.
So increased latency gives you better reliability?
Increased latency gives you the ability for LRT to be applied more, if you will, so the quality can get a little bit better. So one really good example is if you watch Fox News or CBS, all the newscasts have this wonderful shot of the White House or shot of Washington, D.C. There's some static shots you'll see from time to time, but every network seems to have the same type of static shot. Those are lockdown cameras that they all have, the networks have up in D.C. Those shots typically, if I'm not mistaken, Sebastian, are at 10 to 15, even 20 sometimes set for delay because they're just beauty shots. I mean, they're just lockdowns. And any of the affiliates around the country can just take those live into their morning show anytime you want. But when they're doing interviews and talkbacks, it's always set to 1 second. Any other questions? Yes? Yeah.
That shows the extender operation versus the non-extender operation.
Yeah, there's a question, the questions, that's right, there are questions regarding our extender, and if there's a graph that can show you the improvement in the spectrum of available bandwidth when you're using it. There is, within LiveU Central, the management portal interface actually shows you the graph of every single one of your modems, how they're performing, the bandwidth they're getting, and the spectrum can be looked at for the extenders and how it's performing.
All right, that's good. That's good stuff.
Yes?
What's the latency on the Solo and on the graphics package? Can that be done from a mobile app or how's that going?
Yeah, so the Solo delay is approximately right around 5 seconds, somewhere in that range. But it's also, one thing when you're talking about the Solo, you have to take into consideration your CDN provider, because all of those vary. So YouTube and Facebook and Wowza all have different automated delays that they set upon themselves that we have no control over at all. But on average, the delay of the Solo device is around 5 seconds, not adjustable. Your second question was regarding the Solo graphics platform, which is yet to be released. We don't have all the details on it yet, so I'm not 100% sure of how it will be deployed, except that it will be able to be accessed from an iPad or your cell phone or your web browser on a Mac or PC. So any of those will be able to operate the Solo graphics application in the future.
What is the form factor of the Solo?
The Solo form factor, we have one on the table out there. You can
Okay.
see it when we go out there, but it's a small unit, less than a pound or about a pound. It's a clip-on unit that wears on your belt. I think I have time for one more question. Yes, one more question, and you'll be it.
Okay. Obviously, you're constantly innovating and expanding your product line and features and benefits and stuff. If we were to buy equipment now, and as things improve and new technologies come out within your product line, what does upgrading and things like that look like?
Sure. So excellent question, and I'll start off by saying, you said obviously we're always improving and updating our technology. Yes, we are. But I will say your question was specific to upgrading. So we offer purchasing as well as leasing of our products. And if you're under the leasing program, you're always upgraded to the new models as they come out when you request it, as desired by you, not forced by us. If you decide to purchase, and let's say you're 2 years into it and you see something new come out, like the LU600, and you say, I really want to go to that.
Check, 1, 2, 3. All right, looks like we're cooking gas, guys. Evening. We good, Tom?
Yep.
Okay.
You're already done. Okay.
Yeah, we're all going.
And there's a pointer if you want.
Sure. Put this away. Get a pointer out. Hi, everybody. I'm Chris Burgers in NewTek. I am a workflow specialist. I'm also the Northeast Territory Manager, which means you guys are in my territory. I am out of New Jersey along the coast, so we got hit pretty bad by the storm. Not as bad as you guys got hit out here. But we're here today to talk about check, 1, 2, 3. This is how we're going to talk. Okay, I'm just going to hold the mic. We're still good? We're still working? All right, cool. So why be software driven in your production facilities? You guys have traditionally been hardware driven for the entirety of your lifestyle, so let's see what software is going to give us. Obviously, we want things to be upgradable. One of the main things that we leverage in NewTek is that we are constantly upgrading and improving our feature set entirely for free. So a system you bought 4 years ago today can leverage all the new advances in technology simply by updating the system. We want customization. This is sort of something that we don't get in traditional hardware, but is possible. But NewTek software and hardware combinations always allow for customization of different kinds of inputs, video formats, flavors, sizes, streams. That's one of the things we've always hung our hat on. Obviously, we want these things to be affordable as budgets start to shrink as we go forward in the years. We want to be able to afford all the things we have. Accessibility, continue to develop, and obviously we want these things to grow with you. When we're talking about growing with you, one of the things we're really talking about is obviously the move towards 4K and IP specifically we're going to talk about, but as the video formats continue to push forward and change, we don't want to have to always buy a new piece of hardware to support something that's brand new to our work environment. How do we want to do this? We want to be able to handle all aspects of the production by putting all your pieces of the production onto the LAN and then having it accessible to the production studio. We do this via NDI. So let's talk about some traditional ways we connect our studios. This is very old school now, but we have our switchers and we have some file serves here, some video playbacks and a bunch of cameras, and everything was just home run SDI. This is the way studios were run for a while, right? This camera connects to this guy can switch all these different sources. Switcher A, B, and C, and D, each one's sort of its own little platform. It handles what it can handle. Obviously more contemporarily, we have the video router. All our SDI hits the video router, and then it gets repurposed to all these different machines. So everybody has every source technically because they're all routed to each piece. And this is sort of the paradigm as it stands today. We have 12 different cameras, and every system can access every camera because it's a piece of SDI that hits a router, and then there's, in this time, it goes 4 times over to each switcher. What we would like to do at NewTek is to change the setup so that this little dotted line around the edge here, that represents the network. And each of these systems is on the network, but our video playout systems are on the network, some of our cameras are on the network, and all our storage solutions are on the network. And what that means is that we can do something very unique. This camera over here that's directly connected to this switcher can be accessed by this switcher with a 10 millisecond delay from point to point. That's basically what NDI is in a nutshell. And we're going to explain it a little more, but the whole idea is that all of these sources are now on our network, and any single device can access and look at one of these sources and utilize it for whatever tasks it needs. So this is how we normally look at our NDI setups. In this piece right here, we have the TriCaster TC1. We have that in the other room next door. And everything's just connected on the network in some way, shape, or form, whether it be our replay systems for sports, some kind of editing solution, social media, streaming coding, the ability to access and set up multi-viewers, the ability to make video calls over Skype or some other software, graphics systems, your VizRTs, your Chirons, all your cameras, video playback, even teleprompting, all that's going to be now done over networking with NDI. So we're going to enhance our productions. This is an IP series in the field. It is handling over 44 IP NDI streams. It does 44 in, 44 out. It's a 4-stripe system. Each one of those stripes is assignable, so you can control independent outputs. You can control independent mix effects, make your DVE moves. This is sort of the broadcast behemoth that NewTek has had for a little over a year and a half. It's the IP series. A lot of things like Skype calling within our systems with Skype TX. Allow you to leverage cell phones and new graphics softwares as they roll out. And then finally sort of change the way news is being handled by reducing the amount of gear that needs to be done on site. We also have to deliver to a bunch of platforms, obviously. We have just as many viewers on their iPads and cell phones as viewers in our stadiums, as viewers in our corporate networks. NewTek has all these different pillars covered in a variety of ways, but the whole idea is that NDI is driving all of these, and all that NDI cares about is a piece of video content gets on the network. We don't care about the initial size, if it's 1080, 720, 480, 4K, 8K. We just need to be able to deliver it. For us, it's all data in bytes. This obviously transitioning all the way down to the school level. So let's just discuss, we've been talking about this thing called NDI. It's the Network Device Interface. NewTek made it. 2 years ago, released this at NAB. It's a royalty-free protocol. it is not just a cable replacement. I think this is going to be the big change in what we're going to discuss today. There'll probably be a lot of questions about this. But the whole reason we develop NDI is not just to replace SDI cables. We want to leverage what's happening in the IT space to better our productions. This last piece is very contemporary. Within the last 2 years, our third-party development network has exploded. Before NDI existed, we had about 70 working third parties with active developing products. Since NDI has come out, we have almost 500 partners with active development in either software or hardware, and that's reaching over 1 million users already. So NDI isn't a thing for the lab. It's already in use in a lot of productions today. Sort of the magic here is how it does its connections. NDI is auto self-discovering. So that means if I put 2 devices on the network, I don't need to do any configuration with IP. They will assign themselves a name, they will say what their sources are, and they will begin to cross-communicate. It does all the encoding and mixes signaling, allows for recording, and allows for viewing, most importantly, so that when you need to just open up a system and say, hey, look, I want to see what the output of the system looks like, and look at your bars and scopes, all you need is something as easy as a laptop, because all of these things are on the IP, and therefore they can be viewed in a lot more easy ways. Obviously, we can mix signals. I already talked about 4K integration. The TC1 does 4K today. Out in NRB, there was some Japanese guys testing out 8K NDI workflows. So NDI as a platform for getting video across is sort of already at the edges of technology. Most of NewTek's hardware is a little bit more contemporary. NDI is lossless over 1,000 generations. You can take an NDI signal and go 1,000 times. You'll see no degradation of picture quality. It will look the exact same as when you put it in, over 1,000 times of NDI. So all the things we're looking for in the broadcast environment, NDI is already doing. What's the difference? We're going to maximize the benefits of the IP. So what we're looking at here is that we're not just changing out the cables. When a source comes in as NDI, it's now available for anybody else to access. So how would a source turn into NDI? Well, let's just say in that room over there, we have a camera hooked up to our TriCaster. That camera has now just become NDI enabled because the TriCaster is allowing every other system to access that camera. In the workflow we showed earlier, any of those systems that touches an NDI device, whether that be the Connect Spark, the PTZ cameras, or anything like that, becomes IP enabled. So we start to remove away from the video router being involved in our productions because everything just needs to go to IP. Obviously, we talked about the software-driven aspects, how we're constantly updating. But the whole idea is that we want to be able to do our delivery to anyone available, and that in conjunction with NDI being a free protocol without any licensing has allowed us to sort of be one of the most prolific IP protocols in the market. The reason why we get to the places we are is because it works in the field, and it doesn't cost the customers a dime. So let's talk about all the issues. I don't want video on my network. How do we overcome the IT factor? We're going to need more bandwidth. It's a common objection, right? I'm sure you guys have looked at other competing IP standards. You understand that that's going to require a network infrastructure overhaul, whether that be new networking switchers or 40 gig or 100 gig backbones, or new cabling. Hey, all our cables all Cat 5e, now we need to go up to Cat 7 or something like that. NDI works and is designed to work exclusively over a gigabit network. I guarantee you everyone in the infrastructure today has access to that gigabit network. Having a 10 gig or 100 gig network, sure, that can be useful because obviously we can scale with NDI, we can add QoS and things like that, but NDI today only needs a gigabit network. Well, this one. IT doesn't allow us to put anything on the network. We have developed a software for ease of use called NDI Access Manager. If you need to cross subnets, if you need NDI to be a specific flavor or function to work in your IT development, this is where you can do that. This software is entirely free. You guys can download this and start to leverage NDI today in your own networks. One of the cool things Access Manager does is if, let's say, we have 2 different studios and each one's generating 20 NDI sources, you can silo those NDI sources off. Traditionally, we showcase NDI as just this free, open-flowing thing, but if you need to make sure that one studio has only access to certain sources, we can do that in Access Manager. Why would we want to do this? This is a common objection, right? SDI works just fine. Our current cabling systems, nothing's wrong with what we got going on. all these reasons, but I think the biggest one here ends up being cost. I mean, how much cost do you get? How much is spent in logistics and getting connections across, or compatibility of sources, or getting things from one location to another, whether it be sat trucks or radio frequencies or any number of other devices. There's probably networking in all your infrastructure, and you can probably access that via NDI today. It's complicated. Common objection. We've designed NDI solutions to be as easy to use as middle schools and churches. Again, hammering on the ideas of using gigabit networks, not having you do IP integration. There's no IP configuration needed to come out the box. It's a set of solutions, both in hardware and software, that sort of solves this big issue of, I don't know how to work the network. How do I get my NDI working? Well, you don't need to worry about that. We'll do the work for you. For you guys in the sort of broadcast sense, we really want you guys to leverage this to grow client base, whether that be getting Skype integrations or adding to remote productions. NDI sort of simplifies a lot of this stuff. So we see a big growth in the broadcast market professionally for all types of reasons that are just sort of on the fringe of traditional broadcast. Reduced costs, reducing outsourcing, the ability to have instant studios, less cabling, less need for interfacing, less pieces of gear in between. IP and NDI sort of going to be this thing pushing forward in the future. And it really has broad reach when you look at the ability for automation and things in that nature, and ease of integration. So that's going to be the basics of what we're talking about for IP. I definitely want to answer questions before we go into just some of the products. If not, I just have a bunch of the products that we make that may help you ease you guys into understanding, hey, I have this thing that's SDI. How do I make it NDI?
You mentioned that it's a good solution for like churches and universities and things like that. But in broadcasting, what type of redundancy do you have in place? What happens if I lose a switch, or what happens if something goes wrong with my network? Am I completely dead in the water at that point?
Sure. All of the NDI gear you guys are going to showcase on the floor has both SDI and NDI options. So it can be both on your traditional baseband network and on your IP network as well.
At the same time?
Yes. So, and actually we can do a comparison if anyone wants to see the SDI coming out of the camera compared to the NDI. You can just compare both signals. We can pull up the scopes and you can sort of showcase that live.
So if the NDI does go down, you can immediately just move right over to the SDI?
Yeah, exactly. That's the whole concept. Yeah, you just be able to push over to SDI.
It's not like a
Yeah, the whole idea is that both streams are coming out simultaneously. Yes. We also have some failover, like redundancy pieces in the different pieces of hardware. So, rolling over of, catastrophic power failure or dual power supplies and some of the more high-end gear. So, both sides of the broadcast piece, whether it's just the baseband infrastructure or the IP infrastructure, you sort of have both sides of it.
Where did NDI come from? Is it a NewTek invention?
Yeah. So depending on how familiar you guys with the technology, NDI sort of grew out of a thing we were doing in IVGA. That was, let's say, a very prototypical use case for it. It's been in development for quite a long time internally, but like I said, publicly we've had it out for about 2.5 years now. I don't know, it's almost approaching 3 because this will be the next NAB since it's been out.
But it is being offered in the open market, if you will.
Yeah, so the software development kit has no upfront cost, has no cost renewal costs. So it's effectively free. You just download the SDK and anyone can develop for it. And if we talk realistically, I have competitors who leverage NDI in their protocol, in their platform. NDI's growth is a lot due to the fact that it's just easy. You click to download an SDK and you can have it adapted for anything. In a very realistic application, a bunch of churches wanted ProPresenter to be NDI capable. This happened, I think, it's probably like 2016, and it didn't take them long for them to iterate and update all the ProPresenters to be NDI capable. We don't charge anything for NDI in that respect. I'm not sure if ProPresenter ended up charging an additional, but we don't add any cost to that.
And that's where the Panasonic camera vendor
Yeah.
comes in to make them available in NDI.
Yeah, so yeah, Panasonic and LiveU, those guys both offer NDI in their stuff, and they're sort of just looking at the market of, now that we're tapping into all these TriCaster users, the numerous ones, because although NDI is on the contemporary products, we did update the old systems to have NDI capabilities as well. So you look at that user base and they say, hey, we want to have PTZ cameras. The whole NDI thing is ease, right? I plug it in, I give it power, and then I just leverage that source. So Panasonic and we actually also developed our own PTZ camera. So yeah, we'll go through the products and we can go through those. But yeah, the whole idea is these companies are now looking at this user base and saying, how do we, everyone says that NDI is easy. We want our products to be easy and therefore accessible as well. Yes?
Does it also carry control signals and time code and other stuff?
So actively it carries video, audio, time code, metadata, and it does carry camera control. So camera control came out with the PTZs. Technically it was already there, we just didn't have a thing to use it with. The number of things NDI can carry over a signal is quite vast. But the idea is that we're developing this NDI platform both practically and also for the future. So we're trying to continuously future-proof that. If that needs to be AK implementation or some kind of specific kind of metadata, it will be able to allow for that as continued development goes forth. But today, now, you can do camera control. So in the other room, the PTZ camera is completely controllable over the control surface of the TriCaster. But also, when I run my laptop, I can run a piece of software on this that's free that can control the PTZ camera, do pre-select shots, control zoom, iris, select the bit rate it's putting out. So levels of control at the highest end all the way down to the laptop end. Yes, sir?
How's the security on that? I mean, Wi-Fi,
Sure.
I've been in situations where we've had cameras opened up and people are just like, find the camera controls, take control of it, now you've got that control.
Yeah, so...
which was very interesting to explain to the client.
So let's just take the PTZ, for example. That uses the NDI high-efficiency protocol. We didn't talk about that explicitly, but basically we have two flavors of NDI. We have traditional NDI, which is 10 milliseconds from point of ingest to point of source acquisition. So you punch something live, it's only 10 milliseconds delayed from where it is. Then we have the high-efficiency protocol, which is what the PTZs use. So at no point in the NDI traditional infrastructure do you have to touch any IP stuff. So if you guys set out to give it a specific IP that someone could access, they could go that route. But traditionally, NDI is leveraging the MDNS layer. So at no point does anybody have specific access to, this IP is this camera. Could you enable that? Of course you could. We do allow those features, but traditionally, all the NDI stuff is just turn it on and go with it. And all the NDI tools that are free, for the most part, outside of Access Manager, there's no IP configuration of anything. Can you hard code this stuff? Of course. When we think about hard coding for NDI things, that's technically we're going to do sophisticated network stuff and things like that. So that's sort of where you hit those edge cases. But for the most part, while that data is there, it's not native. There's just DNS stuff. So whatever the server serves it up, that's the IP it'll use. So you're liable to anybody hacking the DNS table. It would be a feat, and it's not something easily done, but technically possible.
Are any major networks using this technology now? And if not, what do you think?
Sure.
Major League Baseball,
Yeah.
NFL, the Olympics. When do you think they start incorporating technology like this for those productions?
So I will say that the part of the SDK is also, we can't talk about the development. So there's a lot of companies that have NDI applications that are entirely internal. Not every NDI piece is something that gets sold or is a software or hardware that you can purchase. Major networks that are already using it, I know it's at NBC, I know it's at MTV and Viacom in general. MLB Advanced Media, before they spun out, were huge fans of the things we were doing. In more contemporary markets, we've also seen a lot of growth with the streamers. Twitch TV is a big proponent of what we do. So it's already in a lot of installations. It's just sort of they're doing something very specific, whether that be entirely automated news or something like that. All these things are happening via NDI in some respect because of how network efficient it is compared to a lot of the IP protocols, which means that they don't have to invest a lot into some kind of specific hardware. They can sort of get it running on their own time. Unfortunately, NDAs prevent explicitly talking about that kind of stuff. But I mean, you guys are connected within the SMPTE community. I'm sure you guys have somebody who's leveraging this to do some kind of weird stuff. So broadcast installations already using NDI. The Skype TX talk show, that's got NDI built into it. So anyone who's doing any kind of Skype integration, they've already got NDI. Obviously, all the TriCasters and tons of sports infrastructure at the collegiate level is very big proponents of NDI. So I'm sure there will be a growing use case and base as those guys continue to push forward. I think because NDI sort of mixes with this IT space very well. A lot of those projects are a little bit atypical from traditional broadcast. I think they start to look at, okay, this thing is so IP ready. What can I leverage in that space that'll sort of make my production easier? And they sort of do hybrid systems with their existing gear.
Another unfair question for you. Why would we wait for SMPTE 2110 then to come out if NDI is a great protocol?
Those I think...
It seems like NDI could absolutely replace 2110 in a second.
I think those are solving different needs. I think the nature of what the 2110 spec is trying to accomplish versus where NDI was started. I mean, NDI literally started as, we want to be able to get as many sources on an IP so that your churches and middle schools could do IP tomorrow. That's what our market was. Our market didn't start at the high-end professional broadcast level. That actually grew as a demand because some people saw what the technology was capable of, and then we developed stuff specifically that tackles broadcast. So when we go through the products, we have an output module that's literally specifically designed for rebranding news organizations. So you want to take your news segment and rebrand it in 4 different languages, we have stuff for that. But that's sort of grown in the years since NDI has been out. It wasn't the initial idea for it. Again, NDI can work entirely with SMPTE. It can work. It already works with Aspen and Evertz. So there's lots of cross conversion and reasons why people like one over the other. I think what's grown NDI is sort of the ease of accessibility. Is sort of the biggest growth factor. You have time?
How much time do you need?
I could just take like 2 minutes and run through what we got going on.
That's fine.
So I just want to go over some of the products. We have some of this here. We already talked about this piece. Okay, just quickly in acquisition, we have on the very low end the Connect Spark. This is a throwdown box. Plug a camera into it or HDMI or an SDI source. That source just became IP. If you need to run an IP infrastructure in less than 3 minutes, put a Spark down, set up a laptop on that same network, you now have IP video going across your network. For more sophisticated installations, we have the Connect I/O. This guy goes up to 8 SDIs. It does NDI in or out. So you can configure this to be a 4 and a 4. So 4 SDI to NDI ins, 4 NDI outs of any sources because that's the way NDI works. It also does quad link for 4K acquisition. The PTZ we talked about. Some of our friends here, Panasonic and LiveU. Panasonic will talk after me. LiveU just spoke. Some free applications, and obviously the phone application. Just look at some of this stuff. Panasonic switcher, which you guys don't have, I believe, with them, but that's also NDI enabled. The bread and butter, TriCasters and IP series. Those guys are obviously IP enabled. These are sort of the new stuff. I think a lot of you guys are unfamiliar with this stuff. NewTek has a partnership with Viz Graphics. That's the NVG1. It is the first ever, I believe, entirely IP Viz Graphics solution. There's no SDI in this box. So it comes in a single and a 2-channel. The 3-play replay machines, those are now all NDI compliant. So if you have a 3-play and a TriCaster, you don't need a router for the 2 sources. They can handle 8 cameras. We also have the Talk Show, which does Skype TX. With the new 3-play, we introduced a new version of Telestrator that has transport controls. So the Telestrator app on someone's Surface Pro can control the video playback coming out of the 3-play. And finally, all the things we do for distribution. MediaDS is a collaboration with Wowza that'll stream to any endpoint. It also has a Wowza server built into it. We talked about the studio expansion module briefly. This allows you to pair an NDI signal with another layer. We solve transmission to webcam things like, let's say, Google Hangout or GoToMeeting. IsoCorder Pro, hey, we have all this stuff on the network, I want to record it. And Studio Monitor, entirely free application, lets you view NDI sources. Thank you, gentlemen.
Thanks for putting up with us, the microphone. So for our next talk, disconnect that. Our next talk is, yes, sir. Stuart Lamb and Rick Lamb of Panasonic.
And what's funny is, I came to work at Panasonic, and I was introduced to Rick Lamb, our business development guy for the Mid-Atlantic. And my name's Stuart Lamb, and we both have a B at the end of it, and we're spelled exactly alike. So immediately we began asking, where are you from, where are your relatives from, and all that. And we're not related in the least. Even worse than that, there's a woman named Pat Lamb who's in our marketing department. So I get an email from Pat Lamb about once a month, and that was my mother's name. So that's a weird email to get every month. My name's Stuart Lamb. I'm the regional sales guy for the Mid-Atlantic region. Rick Lamb is our business development guy for the Mid-Atlantic region, calls on broadcasters, all the TV stations, and helps out with kind of all kinds of things. We've got a really great team of folks with, are you good? I'm launched. Are you okay? Got a great team of guys. I had Rajesh Ladd here earlier today. I sent him, he had to go to Burlington to help out with a training tomorrow, so I went ahead and sent him out. But we've got a guy who's a sales engineer. He's got 20 years of experience with Panasonic Pro Video. It's amazing. I mean, he knows everything from before a lot of people got into Pro Video, which is great. And Rick's a wealth of information, too. We're going to kind of, we sort of played with this earlier, but Rick's got a really good brief presentation. Part of what we just wanted to talk about was with Panasonic Pro Video, it's kind of an overview of all of these different verticals that we now participate in. It'll be a nice overview. We've got plenty of time, and we can answer any of your questions. We'll be glad to meet with you wherever and whenever you need to with any of your friends to talk about our stuff. I would be remiss if I didn't lead off with that at CES right now, we have announced that, for those that don't know, 2018 is the 100th anniversary of the founding of Panasonic. So it's a pretty major milestone, and all through the year with the Olympics and everything, and obviously our relationship with the Olympics, we're going to be talking about our 100 years. But this is just one nice little niche of what we do, so we'll cover some of that. So with no further ado, Rick.
Yep, thank you. Can you, okay on the audio back there? I don't, check, yep, good. So, yeah, it's mostly a technology overview of what Panasonic does with image capture. That's where we're going to focus a lot about image capture, sensors. But we're going to hit on how from that image capture we tie into NDI and IP applications because there's a whole variety of ways to move files and video around. But so just again, mostly a focus on cameras. To start with, Panasonic over the past few years have developed a sensor technology more geared for the cinema, creative, the movie type of cameras. So it's we came out with the VariCam series of camera that has this patented new, it's a 35 millimeter 4K sensor camera, which is really taking off in the industry now for movies, commercials, for many reasons. But one of the real key reasons on this sensor, and again I want to just kind of go through these sensor capabilities, but it's what's called dual native ISO, and it's really, it's an industry game changer for these cinema creators. And so what dual native ISO is, in the broadcast terms, it's gain basically. You have a zero gain or dBs and so forth. So for example, at native ISO 800, you take this camera out in the field in the daylight. During the day it's beautiful pictures, you capture all the color, the image, dynamic range. But as the lights come down and you start to get into lighting like this room here, you can go into a native ISO of 5000, and the sensor, every pixel on that sensor then will change to a different type of capacitor, if you will. So now all the noise goes away, and we have this, for example, this is a good rendition of what we shot. So you see the background, you can barely see. This was shot at NAB 2 years ago. So the light is lit by a candle, and we go to native ISO of 5000. The image sensor picks up more than what the eye can see, and it's without noise. So it's just really a technology that's changing the industry as far as cinematography, commercials, where you can go to a scene where it's dark. You don't have to bring lights, like we have here. You can you can shoot using available light. So it's a huge technology.
Well, from a game you said game changer, and part of that is your ability to shoot in practical lighting. So if you're out working on something, you don't have to spend a day with a bunch of gaffers setting up gantries of lighting and rent a street corner and get the cops to block it off. You literally can go out and get that 3-minute shot and then go into the bar and get that 3-minute shot and go into the house and get that one and get in the car and go shoot that. And what has happened is the industry is realizing, kind of with the lead of Netflix shooting all of their content with it, that you can dramatically reduce your costs of production, your daily costs, by shooting so much more in a compressed time frame, and also reduce your work in post because you're shooting with exactly the same camera in all of those conditions.
Correct, yeah. Yeah, and so that the shot of that VariCam, again, a little bit, higher price camera. It fits in a certain niche of production. We, again, just stemming off of this large sensor technology, we recently introduced a much more cost-effective part of that higher-end camera into like a handheld run and gun, but it's using still a large single sensor, 35 millimeter sensor. It's more of a handheld camera, but it's very cost-effective. But it has that dual native ISO capability. So this, again, we're getting just a big response to this type of camera in a certain type of market. So won't talk about price or anything, but the features, we do have one here to look at. The theme of what I'm building up to is, again, kind of that cinema side of the market where typically a large single sensor, DSLR cameras are shallow depth of field, that real kind of creative, nice bouquet look on those cameras. So we came out with a couple of new cameras. Again, these don't have that dual native ISO, but they are large sensors, like a 4/3 inch sensor. Again, kind of a shallow depth of field, that creative services desire for interviews and things like that. And then another new camera, which is a 1-inch single sensor. So, different applications.
These end up being almost the same price at entry-level pricing of cameras, and for pro cameras. And you kind of say, well, why would Panasonic build two different cameras that are basically in the same market area? And it's exactly what Rick just said. With the Micro Four Thirds sensor in the DVX200, you've got a 13 times optical zoom with that large sensor, and you can do great depth of field focus and so forth. That camera has ended up being the choice of virtually all of the film schools as they adopt new cameras to teach the kids how to learn what you guys all know. And so right out of the gate, University of Pennsylvania bought 65 of them. High Point University down in North Carolina bought 40 of them for their film school. And most recently in Pittsburgh, Point Park University is trying to create an East Coast version of the best West Coast training that exists out there, and they bought 32 of the DVX200s. On the flip side, the UX180 is a smaller 1-inch sensor and allows us to do 20 times optical zoom with a very wide field of view at the short end. So that camera is great for a run and gun thing, or for a sports teams, all the college sports guys, where they're handing off 5 of these to guys to go shoot end zone, up in the press box, on the sideline, shooting players, editing it into, helping the coaches understand what each player's capabilities are. This is a fantastic camera for that. So you got two different cameras that serve different purposes. And in the broadcast area, we've even got folks buying 1 or 2 DVX200s and 5 to 10 of the UX180s because of different purposes. And the camera person can say, oh, well, I'm going to go shoot a documentary, grab a DVX200. Or I'm going to go do all kinds of stuff today, and I get a UX180. It's just two different cameras for kind of two different purposes.
Yeah, just a quick point to Stuart. All the new sensors Panasonic develops nowadays are 4K, but probably 80% of the cameras are still, shooting HD, which, has its own advantage and quality. So, regardless of we talk about 4K all the time, majority are still, shooting HD. But again, I kind of made that point about large single sensors. So as we kind of shift looking at studio cameras, box cameras, and we'll talk about ENG cameras where you need that long depth of field, the sports where you don't want shallow depth. So we've developed a whole new studio camera technology along with box cameras. And we're using that technology, and this is pretty exciting because especially when you go to 4K, higher resolutions, we use just a single large sensor rather than three 2/3 sensors, you know, the RGB using a prism. And so especially in 4K, we can get much bigger dynamic range, much bigger color palette out of a single sensor using the Bayer pattern. And then internal, rather than a prism, we have this expansion lens. So it allows you to put a standard, your B4 mount 2/3 inch lens, you know, on the camera head. It expands it to take advantage of the full large sensor. And so one is it's lower cost, it's lower power, and it has a much better dynamic range. So we have you know, HDR capability now, all that in a lower cost studio camera. So I won't go too much into this, just, you know, having bigger pixels comparing to a 2/3 sensor with much smaller pixels, you know, we can gain a lot of advantage here.
You're going to have a lot less energy hitting really tiny little pixels than you're going to have bigger ones. And you're going to get diffraction as you try to hit one that's right next to another one. So with the big sensor, you've got more energy hitting the pixels, and then the camera uses a lot less power, which becomes very important also.
Mm-hmm. So similarly, in the same category, you know, more and more studios, you know, whether you have a studio camera, you have a companion box camera on a jib, or a beauty camera outside, or even now the PTZ cameras are filling the place of studio cameras. But similarly, you know, we've developed this new box camera with, you know, hybrid log gamma, you know, different 4K outputs. So same idea there. But one point on these new cameras is HDR, and I'm sure, I presume everybody kind of knows what that is. It's a big momentum, especially HDR versus 4K. You know, there's a much bigger impact if you can do an HDR in HD for the broadcasters versus just, you know, a 4K distribution. So it's the same bandwidth. But I think we all know that the new displays, whether it's consumer, and actually Panasonic has a new consumer display in Europe that's 1,000 nits, you know, super bright, beautiful display. But with HDR, the idea is versus Rec 709, so a standard TV that we're all used to today, you know, this white here you see would be the same white as the sun, you know, and that's just kind of what we're used to on TV today. But using HDR, we can take this white here, you know, at a brightness of like 300 nit, but the sun is obviously now, you know, 1,000 nits. So that dynamic change is really an impact in the industry. And I presume, I don't know if everybody's seen that, but it's really a much greater impact than just looking at 4K displays. So these new camera systems have that using hybrid log gamma is part of HDR, but it's a live output as opposed to post-production. So, okay, so, you know, that was a little bit on the sensor technology, but on the next step of image capture is control. And then we'll talk about NDI and other things. But this is kind of Panasonic's real focus on all future products and connectivity, and that's, you'll see on the left, we've developed these new ROPs, typically for studio cameras for paint and shade control. Well, those are all IP network, PoE, by the way. You can power most of these things from power over Ethernet. But we can tie it into all these different types of cameras so that a single ROP can paint and shade and match all these various cameras from outdoor to studio to E&G cameras.
Can one CCU manage them all? It's not fair.
Well, not a CCU, but the ROP, the remote operating panel, yes. So you can one panel,
One
yeah.
for 19 cameras.
Well, no, these new ones are 100 cameras.
100 cameras on the new ones.
So there's a simple camera select. You dial it in, punch it. There's some intelligence with the knobs so that, you know, when you switch to a camera, it doesn't like raise the iris right away. It gives you some flashing, and so that's kind of the idea there.
Can you affect several changes on different cameras at one time, or at least do one at a time?
We do have an MSU, a master control unit, but today it doesn't kind of reach out to all the cameras. So you know, it's a good question, something we can lead to, but not all at one time. But there are presets, so that, you know, there's ways to trigger presets to get to a preset position. So just shifting to PTZ cameras. So this has been a huge success for Panasonic as far as the, you know, PTZ cameras for a couple of reasons. One is we're seeing a lot more of these type cameras going into studio applications and field applications and outdoor applications. So it's a big thing. NDI is a big discussion here. So this just gives you an example of a few models. One of which is new is we've got a fully outdoor camera that we have in the room here. It's got the wiper, and it's got some nice features with the washer fluid and things like that. It's fun stuff to. I'll show you if we get time afterwards.
Well, compared to the DotWorks enclosures with a dome, it's much smaller. You don't have to hang it and look down. You don't get diffraction off of the dome. It's heated, cooled. It's completely weather resistant, right side up, upside down, whichever. And has two different types of image stabilization in it. So I always joke you can put it on a pole out by the beach and watch the hurricane come in. But it's a cool camera. Even the paint on it is meant to last long term and to control temperature inside the camera and so forth. So it's a very well thought out piece that we've been working on for a long time. Yep. Good question.
Does the wiper handle spider webs?
If it's on the surface, yes, but not if it's going to be between the hood and down from that. But hopefully you're going to look through a spider web.
Just a quick story on that subject. A few points. So KYW here in town have a bunch of these smaller profile cameras outdoors, and as Stuart mentioned, you know, those are in dome systems that, you know, they are what they are. You can't, you know, look up at the sun or anything, and they're somewhat limited, but they work. They're great for them. So they actually install these cameras have 3 sensor cameras, so they're a little better lower light, you know, a little higher end. These are the ones going in the studios. Well, the dome that we developed for that, or not we, but DotWorks, it's, you know, it's a big thing, and it's, you know, not very cost effective, but KYW has had a beta unit. They put it up in the Poconos, and so we were there one day doing a demo, and sure enough there was a spider web across the dome, and it was like, there's no way to knock it off. Or, you know, it's a true story. Anyway, that's so these PTZ cameras, the point with this slide is they're designed to interface with just about any other third-party application, from you know, Visca control, telemetrics uses the protocols. So it's a, you know, it's a wide range of control connectivity. But one of the real key points I want to point out here, on each of those cameras, they have encoders built in. So the encoders will generate a stream over IP, you know, RTSP, H.264. But it's not just one stream. You know, you can extract up to 4 different RTSP streams, and they're all associated with the IP address of that camera. And just to point out, all the new cameras now have NDI encoding built in. But with the 4 different streams, you can go up to 24 megabits of compression, which is, you know, typically broadcast is around 6 megabits. So it's, you know, you can extract really high res, or you can repurpose to a website. You can repurpose to in-house TV, or even low res proxy streams, and that's important for the next slide, which is to be able to take video stream from each camera over a Wi-Fi network, for example, and see that without, you know, without much problem. So leading to that, we have a range of these control systems. There's hardware and software, but the software control is unique because it takes advantage of the low-res video stream from those cameras. You want to talk a little more about that?
There's a lot of different ways to control our pan tilt zoom cameras, and we've got a lot of these out here. We make two main controllers, which are joystick and pan tilt zoom controllers. They both do the same thing, different sizes. In the RP50, which is the smaller one, they're buried into menus somewhat, so there's a limited number of buttons on the surface of the unit. In a lot of cases, people will pick an RP120 because you can paint and shade directly from the surface of the unit. So you can shade the different cameras on the fly directly from there. Also has a bunch of buttons on it. Well, they serve multiple functions, but in a lot of situations you want to program a number of different presets. Our pan tilt zoom cameras are often used in county council rooms and courtrooms and places like that where high reliability, long-term, long life is important and really high quality pictures. Well, you can preset it for dais position number 1, 2, 3, 4, back out here in the audience where the testimony position is or whatever. And the operator each day or each meeting doesn't have to be the pan tilt zoom guru of moving the camera around. They can have a cheat sheet and they can just push the button for whoever's talking and it goes to them. And it's not a jerky, fly there and freak out kind of action, which we've all seen. It goes there and it has a nice soft landing as it goes to each location. You can also, in here, memorize complete traces, which is really nice with everybody doing web videos and YouTube videos and whole series of things, and they want a consistent look to that. One of the things I always point out to folks is you could focus on your logo, practice 10 times, backing out, and then coming over to the dais where you're speaking. The 11th time, you memorize that move and save it as a preset, and then you do the opposite move and save that as a preset. And then whenever you're going to do your little 12-minute YouTube video on a subject, you just have somebody push 1, or you do it, push 1, and it does that zoom to the position, and press 2 at the out, and you've got the exact same in and out take either way. So they're very flexible. Both of these have 5 serial connections for up to 5 of our cameras. Okay, well that's great, that's old school. You can simply plug them in and you don't need anything else. You don't need a network near you. The vast majority of the time now, we can now plug in up to 100 cameras can be controlled from either of these controllers, and you can put up to 5 of these controllers on a network. So great example, Temple University is building 2 studios where professors come in and are going to do their little bits before they record them for classes and so forth. You'll be able to have 2 people in 2 rooms running 2 systems. But if somebody doesn't show up and you've only got 1 operator, well, that 1 operator can control the cameras in both studios. And it makes it really easy. And with the streams, like Rick was talking about, you could even pull up a stream and see a camera and move it remotely from somewhere completely different, a different building on campus or whatever. So a lot of capability there. These 2 are great. There's ROPs, as Rick was talking about. We even have a little handheld remote control for IR if you want to do that. There's a brand new NDI switcher controller that's launching in the next 60 days that you will see from us, along with a whole new bank of cameras and or upgrade capability to the existing camera line. One of the things you were talking about is you could take this little proximity camera, look at a view. If you've got a conference room and you just want to set it up, you've got an iPad, a conference room, that proximity camera is on the lower level of this screen, and you can just see the image of the camera and point it anywhere that you want to go. So a very simple control system. A year and a half ago, we introduced a facial recognition auto tracking software. Works on PC. It's very simple. You need some horsepower in the PC. You should have ample RAM available because it does process the face that you take a picture of, and then the camera will follow that face as long as they are up there on stage. It's really nice because with the facial recognition in an educational place, the instructor can be up there, students can come up and work on the board, work problems, present, and it can stay on the instructor, and you get away from this lecture where you're looking at the entire stage and it's completely non-compelling video, because you can actually look at the instructor, and as they move around, it follows them around. And it has a very nice algorithm. When you get to the end, it kind of moves, and then it follows, and then when you get to here, it kind of adjusts. So you don't get a jerky motion around the room or whatever. That's the AWS-F100. If you have a Panasonic camera, you can download that for free from our website and try it for 30 days and get addicted to it. Later this year, we're going to introduce a server version of that that'll run up to 4 rooms or 4 cameras in a room on 4 different subjects simultaneously. So obviously, with a limit of 4 per server, you get an idea of it does have some processing power needed to run that, but it's really, really nice. And then you're going to talk about the live app a little bit more. But there's really a wide variety of ways to control these. And what we don't even have up here is, as Rick said, you can hit the IP address of any camera on a browser, and you can control the camera directly from your browser, too. A lot of flexibility. I don't know what's next up on there.
I'll just a few minutes. So you heard NDI or NewTek. We've been working with them for a couple years now and have developed the NDI integral to the PTZ cameras. And the one little switcher there that Stuart mentioned is in collaboration with NewTek. So it is a big deal in the industry as far as that protocol and what's capable and what's possible. So Panasonic is fully engaged with that technology. So this little switcher, for example, is a collaboration with NewTek. You can stream cameras into it over streams. You have HDSDI ins, HDSDI output, or stream output to Facebook. So it's a nice combination of production switcher with graphics, wipes, keys, and full PTZ control. So again, kind of tying video over IP, control over IP, and
real medium, and then you do titling on it. So it really gives you a very simple nexus point to do a basic, straightforward system with both SDI and NDI input.
And output wherever you want to go, even up to a live output.
Yeah. All right, we'll just shift gears a little bit. So field production, engineering cameras, kind of shows a lineup here of a variety of product from portable decks. But the point again is it's all about being connected, IP. They stream just like the others. And we'll talk about LiveU a little bit and how the QoS of Panasonic kind of is similar to LRT, I think it was. So they're all connected, and you have different ways to take advantage of this. So in addition to this, we'll briefly touch on iPhone, of course, now has integration in the connected world and decoders. But this diagram just is an example of these field production cameras with they have either a Wi-Fi built in. You have a LAN port on the cameras now, or you can actually put a Verizon USB antenna on the cameras, single modem, not bonded. But once that's connected to the internet, now you have kind of 3 basic functions that you can do with that camera from the station or remotely. And one is control, meaning you can paint and shade the camera from one of those ROPs that we talked about before. Or you can just open a browser and log into the camera from the station and see the clips and start, stop, record. So you can also take a scene file from one of the cameras that looks really good, copy it, push it out to the other cameras. So it's got a lot of capability there. Then there's file transfer solutions. So all of those field cameras, when you're shooting, recording, they're recording high res, but they're also recording a proxy simultaneous. And that proxy video, you have a whole range of choice. It's actually very good quality, easily something you could put on air, but low bit rates. So there's a lot of applications we'll touch on there. Or you can put the camera into live streaming mode, and that's where LiveU, you heard that, where they've got the, the QoS from Panasonic to be able to stream a single modem camera to the LiveU Central. So one application that's really taken off for us, and I'm not going to get in a lot of detail, I'll try to explain this quickly, is again, you heard about LiveU's cloud application, different cloud applications here and there. Well, P2Cast is a cloud, network cloud application. We actually use Microsoft Azure with the Panasonic developed software. So those cameras, if they're connected, multiple cameras through the cloud network back to the station, you have access to automatically retrieve the proxy clips in a user interface, so you can see the camera clips coming in. You can actually see where the cameras are located because they have GPS on the camera itself. You can't tell here, but the idea is those clips are coming in to the producers or to the ingest people, and the photographers aren't, they're out there shooting, they're not stopping, they're just shooting the story. So back at the station, you can monitor what they're doing with time code, metadata, and you can view those clips as they're coming in. And if you have, for example, a half-hour clip, at the end of the day, you just need a 2-minute sound bite from the high res. You can actually create a quick edit here, send the EDL back to the camera, and then it will FTP that 2-minute sound bite high res to an FTP server, not through the cloud, but directly back to the FTP server at the station. So it's kind of it's a term we're calling going media less, so that you don't necessarily have to take the high res media out of the camera, bring it back to the station. You can all do it now, kind of remotely, and it's really picking up at a lot of broadcasters, and I'll be happy to show you that if we get more time and talk more about it. So. So going to the, I guess, live streaming, LiveU, but Panasonic developed this enterprise server. It's a true server. It's not a PC or anything. It's a server. It's a redundant design, redundant power. It'll take the streams of all of these cameras that we talked about, including an iPhone, and I can show you that, but the outdoor cameras, the E&G cameras, studio cameras, all have these streaming outputs. So you can stream it here. This can have up to 4 HD SDI outputs with GenLock, so you can lock them and decode it. It's a really good user interface, drag and drop. But we also implemented NDI in here, so you can take those and stream them out to Facebook Live or social media. Yeah, it's a different group, different department, but it's a good question. I don't know.
I don't know whether
if it's
this
RTSP,
will see them or not.
If it's RTSP, that's a good question, valid, yeah. So any case, just to round it up, so another big trend that we're seeing from a lot of different sports companies is 360-degree virtual reality cameras. I'm sure you've heard of it. It's a trend, seems interesting for a lot of these players. Well, Panasonic developed this new 360-degree camera, and different than what you've seen in the industry, it's a live camera. So typically, the 360-degree VR, you'd have a GoPro or something like that with like 5 different cameras. They go out and you record whatever they record, bring it back to post-production, kind of splice it together and create this clip, right? So that's what it is up until today. There was, I don't know who it was that could do it live, but it was like a $70,000 system. So this, I'll just see if I can. So this camera, the key is it's a live system. So we recorded a sample, and I'll show you this. So this was recorded on a prototype. I don't know if you can see. You can look at this closer later, but the idea is you can, point it up and walk around. I could even look at it backwards. I don't know if you can see that, but so that's just one application for virtual reality. So the point is that camera outputs 4K live, and it's what's called equirectangular, kind of a standard output that you know, looks pretty funky, but it is possible to put it into a switcher and route it, or switch cameras. But the encoder then, as you take it up to GoPro VR or YouTube VR, will, you know, encode that properly so you can, you know, do those kind of applications. So anyway, it's a trend. We're keeping in conform with the other cameras with streaming and IP control and things like that. And
But leading edge technology, the stitching in the camera and 4K.
Yeah.
So
stitching is
yep.
4K, yeah. You can do HD output, but 4K is, yeah.
So for a different use case, could you take this to, let's say, a news service, catastrophic event, rather than trying to get a bunch of cameramen in there with cameras and equipment and all? Set one of those down and let the producer just pick the view that they want in a 360-degree space?
Yes. So, and I smile because there's an interesting application. Typically the application is just that. You go on YouTube and you kind of scroll and you can look all around the environment, right? Because it's there. We did show a thing at NAB this year where, because it's 4K output, we had a processor, and it's a fixed camera. It's just a camera we stuck fixed in a location, and it's picking up everything, right, all up and down and around. Well, the processor would take the 4K input and extract 4 HD SDI outputs. So we ran that to a production switcher, a switcher. So you had 4 shots, 4 scenes. And then we were able to tie that into the PTZ controller. So now you can pick, camera 1, 2, 3, 4, and it had a nice little target thing, but you can virtually pan, tilt, zoom those 4 outputs to anywhere. So it was, I thought it was a neat up.
Or
it's
the
not
other
a product.
side of what you just said is, instead of having a cameraman deciding that this is the shot and doing the editing and what he's shooting, now you have this, and guess what? You get to pick what you look at, as opposed to have somebody else deciding what part of the image you're going to look at. Because you could have the camera sitting there and looking around at everything, and then you decide what you actually want to look at.
And then beyond that, if you have a particularly spectacular 360-degree location, you can shoot it all at once, basically, is what you're doing.
Yeah.
Right.
And if you had a way to display that in a larger screen display system, you could experience that location.
You could immerse yourself in it.
That's interesting. Yeah, you would need a processor to be able to bend the video around in the right way, but that's interesting. Okay.
Similar.
Okay. Yeah.
I can't say any more about it.
Yeah.
How do you eliminate the cameraman's head?
So, well, that's a good point. So from the camera head itself, it is about 36 inches before it actually picks up. So there is some dead space around here.
There's a cone of hiding.
Yeah. kind of like a 5 foot. Yeah, there. That's
cone of hiding.
That's exactly right. Yeah.
I mean, that's a lot of different verticals to cover in a really short period of time. But I mean, we're doing top of the line E&G cameras that broadcasters are using every day to go out and get the news, and a lot of stuff you're looking at. We've got the state-of-the-art in pan, tilt, zoom, and it doesn't mean it's the most expensive. They're good, great E&G quality cameras. We're using them in houses of worship for IMAG. So even the smallest of houses of worship now can use robotic cameras, not where they don't have a lot of volunteers or trained people, and they can have one operator work a bunch of cameras, and they can put it up IMAG, and it's live. It's really nice. So they can do that with both the E&G cameras and the PTZ. Studio cameras, we've got a camera right now that's without equal, and another one coming that's even more without equal in the next few minutes. We can't tell you about it tonight, but you'll see it shortly. And at NAB, we're going to be, we'll have this whole line of new PTZ cameras. So our current cameras are either an HE or a UE designation to the cameras. We're going to have exactly the same cameras in duplicate. They will be HN for NDI or UN for the 4K camera. And they will be NDI capable from the factory. And in addition to that, all of the HE and UE cameras that are out in the market now You can go to NewTek in the next month. Well, it'll be available, and you'll be able to download new firmware for your camera at a modest cost and upgrade any of the existing cameras to NDI capability. So for that new media center switcher, for any of the TriCaster, for anything that you want to do with NDI, it's a way to put the media on IP without crushing bandwidth and crushing a network. It's a very sophisticated line of cameras. They've got great image quality, but we're also allowing you all the different ways to control them and interface them, which is beautiful.
So I was going to leave this slide out, but I decided it's worth it. Panasonic's into drone technology now as well. And so it's for real. I mean, it's a real product, but we've developed the balloon cam. So it's actually being used in arena. You can't go outside with it, but the idea is it's actually a pretty large balloon, right? And it's helium filled. It's got the propellers, and it moves around. But there's several technologies in it, you know, with the camera, of course, whether it's 360 or a standard camera. But there's a couple of technologies here. One is the balloon is white, you know, and it's actually a good projection surface. So with our new laser projectors, they have geometric shaping. So the idea is you can, you know, locate it in a fixed position, project advertising or stats or, you know, live feeds or whatever you want onto the surface, you know, from different angles. But also we showed at NAB a technology called link ray. And this link ray is similar, you know, like QR codes where you take your phone, you kind of hold it over that little code in the magazine or whatever at the store, and it gives you information, right? Well, link ray is the ability to put code into LED lighting. So it actually, in a serial DC form, will put code into that light so that, you know, and with the link ray app, if it's let's say you're in a store and you have an LED light shining on some tennis shoes or something like that, you just hold your phone up, it'll tell you all about whatever you want to know about that shoe and price or discount. If you have an LED display that's showing whatever, it could be an advertisement, you know, link ray will take you right to you know, a free discount or a free beer. So same with this balloon cam. Inside it is an LED light that you can program this code, so the fan base, you know, can, you know, look at it and see if it's like a beer advertisement that's on there. You'd get directions to go get your free beer over at you know,
free soda with hot dog purchase.
Yeah.
$3 off the beer.
Anyway, it's fun technology that's, you know, cutting edge, but it is drawing interest. So
What kind of life do you get out of that balloon before? What, is it rechargeable?
It's helium, so it's quite a process. They have
But the electronics in it, the batteries and all the rest.
Yeah, I don't know.
You'd have to bring it down and put new batteries in it and so forth. It depends on how you're going to do it. It could just be hung in the middle of an arena and stationary, and you could project onto it. At NAB, we were showing it, and it actually had drones up in those little pockets, and it could be flown around inside of an arena. So, you know, there's a lot of cool things that we play with, and they're great ideas. But link ray is a successful technology already. This is just a way to put it into a way for everybody in an arena to see it, because we're doing fine pitch LED walls and show screens for arenas now. We've got sound, and obviously we have the best cameras for those arenas and so forth. So there's a lot of good stuff going on for our 100th.
Other questions, or are we out of time, I presume? Or?
Well, we can reconvene in the exhibit area, and you can ask any questions out there.
Yeah,
sure.
Anybody have any basic questions you need?
Yeah.
Okay.
Thank you very much.
We're in here. Thank you.
And the mic's held up.
Yeah.
Those batteries last a long time.